All right, hi guys. Sorry I couldn't be here today. Take a minute and get out the packet that we were working on yesterday. I want to make sure you guys have a couple questions right on what we were working at the end of the class before we jump into the new stuff for today. So this is data and probability 2, the one that we were working on yesterday. It's the one with the total coins collected on the front of it. Angelina, I believe Miss Smicker has yours with the stuff for this class. So if you didn't get it back, she has it for you. Okay, so really what I want to focus on is I want to make sure you know how to do the main problem because 5, 10, and 15 are all the things that we're going to learn today. But basically there were 3 problems that you were asked to solve. One of them was having to deal with dice. And you had to do things like problem number 1, which wanted you to find the probability that you get a 4 and then another 4 on your 2 dice. Those numbers actually don't matter if I'm just listing them out, because no matter what number that I give you, you should be getting a probability of 1 out of 6 if you're working with dice. There is 1 of each number, so no matter which number I say, you should be doing 1/6 times 1/6. So for number 1, your answer should have been 1/36. And again, if I change those to any other 2 numbers, it's the same problem. Each number shows up once on a regular dice. So all of those problems should have worked like that. I know we had some hiccups on a couple of them, but in the end, 1 through 4, it's just a matter of counting how many different ways you can get the thing you want. Looking at 6 through 10, and again, I'm really only going to focus on 6 through 9 because we're going to look at the other problem in the actual stuff we look at next. Depending on how it was written, when you see this probability where both things are S, this is saying I'm picking tiles out of the bag, and on both of my picks, I get an S. So there are 2 S's in the bag, and when you add up the numbers, 4 plus 2 plus 3, you should get 9. That's going to be 2 out of 9. This was a problem where you're replacing the tile, so your second pick is also an S. 2/9 times 2/9, you should have had 4 over 81 for this answer. Yep. And then the other ones work exactly the same. Number 7 is definitely also going to be the same fraction twice because both picks are a T. 8 and 9, you'll have a different fraction in each spot. Only the numerator will change based on which letter you're picking. And then last but not least, in the remaining 4 problems, this is the one that if you didn't get to, you want to make sure you understand how to do these. Here, instead of tiles, we're picking marbles. Instead of letters, they're colors. But it's the same idea, but we're picking without replacing. So these are the ones where we have to make an adjustment on our second pick. So I'll do numbers 11 and 14 with you guys, and that'll leave the other 2 for you to do if you didn't get this all the way done. Probability of getting a red and then a blue. So we're going to start off the same. We are going to say on our first pick, we have 8 out of, I've added them up in my head already, but we had 3 plus 8 plus 4 off to the side. That gives us 15 total marbles. So red then blue, 8/15 times blue is 4/15. Oops, sorry, not 15ths. The whole thing I was saying, we have to adjust. On that second pick, I have 1 of the red marbles in my hand. So there are still 4 blues, but there are only 14 marbles in the bag. There's not one pair for these 4 problems. There's not one of them where the denominators don't go 15, 14. So before simplifying, this gives you 32 over 210. Be careful with the next problem that I'm going to go over, number 14. This says that I pick and both of my picks are red. We're going to start off the exact same place we started out with number 11, 8 out of 15. But when we go to do that second probability, it's important to realize that not only do I have a marble in my hand, but that marble is red. So both the numerator and the denominator need to get adjusted when I find the probability of getting that second red marble. There's only 7 red marbles left in the bag. And again, 14 is always going to be the number we write in all 4 of these problems. So same thing, this one before we simplify is going to give us 56 out of 210. So that should be enough for you guys to do 12 and 13. If you're still a little fuzzy on what to do on the last problem in each section, we're going to go in a little bit more in depth in that today. So put that one away for now. Put it off to the side. If you need a minute, if you have some time, you can work on that one later. But let's move over today to today's new assignment. So data in probability 3. The front looks like this. Ms. Smicker had them. Hopefully she handed them out. You can work on the front later, but I just want to get these notes out of the way first. Okay. The main thing that makes today's problem different than the problems that we've looked at yesterday is that along the way, there isn't just one thing that can happen at each step. So for example, in example 1, we have marbles. We've got 6 blue and 4 green. So we kept the numbers pretty simple. We are picking 3 marbles this time. So we're going to have 3 fractions to multiply instead of 2. But when you look at some of the questions that we're asking, one like this one down here, what's the probability of getting exactly 2 blue marbles? Well, you could get those 2 blue marbles first and then get a green. Or you can get a blue marble, a green marble, and then a blue marble. So you don't know what's happening exactly along the way. We have to list all of those things out first, and each one of them is their own problem. The same thing down in our second probability that all marbles are the same color. They might all be blue, but they might also all be green. So what we're going to do first in letter A is just list everything that could happen when we choose 3 marbles. So the way we do something like this, and you'll have to do this for just about every problem on this page, we're just going to say, okay, blue and green. So what's everything that can happen? Let's start with blue, and let's say we got all 3 of them blue. Okay, that's one thing that could happen. I got a blue on each pick. But I also could have gotten a green somewhere along the way. So let's consider that one. I could have gotten a green first, and the rest were blue. I could have gotten a green second, but the other picks were blue. I could have gotten a green third, but the other picks were blue. Okay, those things could happen too. Right now I've gotten no greens. I've gotten 1 green. Let's list all of the ways that I could get 2 greens. So we'll start off kind of in the same spot. Let's say I got those 2 greens first. Let's say I got a green, then I skipped over and got a green. Or maybe I got those 2 greens last. Those are really the only ways that I could get 2 green marbles. It's really about where the B ends up going for those the last 3 that I wrote. And then the only thing we haven't talked about is what if they're all green? If you think about it, there is no other way to pick 3 marbles and have anything other than those 8 lists happen, from blue, blue, blue to green, 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 and everything in the middle. So you have to think about these things as you're doing your probabilities. We don't need to list all of them. We only need to list the ones that match our situation. So to kind of point that out, with our 2 questions in part B, we want to pick which things represent exactly 2 blue marbles, and that's the ones that I wrote right here. Those 3 that I've highlighted in blue all mean the same thing as exactly 2 marbles. That means I've got to find each of those probabilities like we did yesterday and then add them like we did yesterday. So let's see, it's just to write it here so I don't have to keep looking up. It's 6 blue, 4 green. Our first probability that we need to figure out is GBB. Green is going to be 6 out of 10. Blue is going to be, did they tell us we were replacing or not? It said without replacing. So there are 4 blue marbles left, and there are 9 total marbles left. And then our second blue, just like I said in that last example we did on the other page, we have a blue in our hand, so that's going to be 3 out of 8. So each pick along the way, we have to take into account what we've already picked. My first pick, do it as is. My second pick, I have a green in my hand. My third pick, I have a green and a blue in my hand. The denominators always tick down 10, 9, 8, like that. All right, so I'll multiply those in a minute, but let's take a look at the other two. We have B, G, B, and we have B, B, G. So now with the middle one, this time I'm picking blue first, so that's 4 out of 10. I have a blue in my hand, and I pick a green, so that's all 6 of those greens out of 9. And I've got a blue and a green in my hand, so I'm 1 blue short for 3/8. And then last but not least, B, B, G. Now I'm starting out with blue, so that's 4/10. I have a blue in my hand, and I want to get another blue. That's 3/8, or sorry, 3/9. I was looking up. And then the green, I haven't taken any greens out, so I still have all 6 of them. What you should notice in a lot of these problems is that no matter which one of these you've picked, you have the same 3 numbers. You have a 4, a 6, and a 3 in some order. That actually means that all 3 of these probabilities are going to come out to be exactly the same. And I just realized that I wrote a 10 there, and it should have been an 8. So those are the correct probabilities. So when we multiply these, we should get the same results. All 3 of these numerators end up being 72, and all 3 of these denominators end up being 720. When that's the case, we can simplify right now. Those all simplify out really nice to 1/10. And as long as those denominators are the same, I can answer my question by taking the numerators and adding them up. And the answer to my question, what's the probability that you pick 3 marbles and you look in your hand and see that exactly 2 of them are blue? That's going to be 3/10. 1 plus 1 plus 1 is 3. The denominator stays the same, so you need to work with, if they all simplify to the same denominator, great. If not, like I think we'll see in the next example, use the unsimplified ones. Okay. So 2 steps to our problem. First, list out everything that represents the probability you're trying to solve. Each one of them is its own separate problem. Sometimes those 3 problems are really the same problem. Add up your results. Make sure you have common denominators when you do it. So you can never go wrong by adding up the unsimplified versions. That being said, 1 plus 1 plus 1 was a lot easier than adding 72 to itself 3 times. All right, next question. All marbles are the same color. So different situation. Now we're saying I got all blues or all greens. So those are the only 2 probabilities I need to find out here. B, 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 and G, G, G. Just like the problem before, our denominators are going to go 10, 9, 8. And since it's the same color each time, we're going to start with our number for blue, which is 6. On my second pick, there's going to be 1 missing, so 5. And on my third pick, there's going to be another 1 missing, so 4. So blue, blue, blue gives us 6 times 5 times 4 over 10 times 9 times 8. and that's going to be 120 over 720. Now with green, 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 my denominators will be the same, but I only had 4 green to start out with. So that means I only have 3 on my next pick and 2 on my final pick. That's going to be 24 over 720. Now we'll see. I don't know if these are going to simplify to the same denominators, so we may just have to use those bigger numbers. 120 over 720 gives you 1 over 6, and 24 over 720 gives me 1 over 30. So this time I do not want to use those fractions because I need to make my answer look like this. I'm going to use orange instead of green. I'm going to use the unsimplified versions, 120 plus 24 over 720. And that actually ends up being 1/5. Again, all of that can come right from your calculator. None of that is stuff that you have to come up with on your own. Okay, so we ended up with 2 situations here. In one, it was really just changing the order of the numbers around, or sorry, changing the order of the letters around, and that gave us the same results for each. So we were able to use the simplified fractions. However, in this was more about coming up with different things, BBB versus GGG. So we use the unsimplified versions. You can never go wrong using the unsimplified versions. All right. Okay. Example 2. There are a lot of questions here. We'll do some of them. I'll let you guys try a couple of them. I want to point out some things in these problems as we go along. So example 2 is cards in a bag, where again, we're picking without replacement. So we're doing this again without replacement. We want to know what the probability is in the very first one of getting a G and an E. So unlike yesterday where we were saying I got a G on my first pick and then an E on my second pick, all I care is that when I look in my hand, I see the letter G in my hand and the letter E. So I don't care which one came first. I don't care which one came second. So we have to figure out both of those probabilities. A G and an E versus an E and a G. We have 7 cards and we've got 1 G and 1 E. So yeah, so that's really easy. Both of these probabilities should end up being the same. Getting a G is 1 out of 7. And then with 1 card in my hand, the probability of getting an E is going to be 1 out of 6 because there are only 6 cards there. Doing it EG is going to work exactly the same way because there is 1 of each card in there. They've just reversed orders. Both of these are going to give you 1 over 42, which doesn't simplify. To get our final answer, we're going to add those 2 things up. The answer to our problem is 2 over 42. I don't like the way I wrote that. It's going to do it separate over here. 1 plus 1 over 42 is 2 over 42, which simplifies to 1 over 21. If you can do that problem, you can do the problem to the right of it, probability of getting an A and a B. Just be careful, there are 2 A's in the word algebra. So that'll make that one a little bit different. Okay. I'm going to go down a question, and I'm going to tell you to be really careful with this one. You could make this one a lot more work than it needs to be. They want to know what the probability is of getting exactly one vowel when you pick 2 cards. You could go to the letters and list out about, a bunch of different things that could happen. An A and then a G and then an A, an E and then an R. But use the words that they're saying. We're getting 1 vowel. That means our other pick needs to be a consonant. right? In the little ELA connection, our vowels are the A's and, I'll use my color here, keep with blue. Vowels are A's and E's. Consonants are all the other letters. So C, 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 C. So in the word algebra, there are 3 vowels and 4 consonants. The A and the E are the vowels. They show up, the A shows up twice. So this is really similar to the problem above. I've got to take into consideration the 2 things that can happen. A vowel first and then a consonant, or a consonant first and then a vowel. These probabilities should end up being the same. I said there were 3 vowels out of 7. And then on my second pick, I need a consonant. They're all still there, but there's only 6 total tiles. When I do it consonant vowel, I end up with 4 out of 7 first and 3 out of 6 next. Either way, they both end up being 12 for the numerator and 42 in the denominator. I can simplify now if I want. I'll get the same result. That's going to be 2 sevenths? Yeah, 2 out of 7. Which makes the answer to my problem 2 plus 2 over 7, which is 4 sevenths. Again, if you can do that one, you can do the one to the right. And then my last example here is the simplest example, both consonants. Sometimes you go to do this and you realize you're doing too much. With both consonants, that means on your first pick, there's a consonant, and on your second pick, there's a consonant. There is nothing else to do here. There is only one probability, and it is your answer. So it's not CC and then flip the CC around. You're writing the same thing if you do that. So it's just both consonants. It's just one pair of fractions. It's just 4 over 7, because there are 4 consonants, times the 3 remaining consonants out of 6. I have 1 consonant in my hand here. That one ends up being 12 over 42, which is a number we've already seen before, and it still simplifies to 2 sevenths. Okay. So sometimes you go to do this and you realize you've only written one thing. You actually have a problem from yesterday, not a problem from today. But, it feels like a problem from today because I figured out every way it could happen. It's just that there was only one way that it could happen. Okay, so you have a couple things to do today. Finish up these 3 problems over here. Then, in whichever order you want, either do the practice on the back first or do the at the bell questions first. Sorry, my screen took a minute to catch up to where I was. But yeah, so your choice on what to do it. Do try to get all of that done. This video is only about 23 minutes long, so you do have 40 minutes to get both of those things done. Miss Smicker does have the answer sheet. Hopefully I didn't make any mistakes on it, but the only way to find out will be to check it. But Miss Smicker does have the answer sheet, so she can check your answer and she can help you out if you guys need it. We'll see you guys tomorrow and we'll clean all of this up then.